So the first question I'm going to ask is, if we would graph this, what is it? Is it a parabola, a hyperbola, an ellipse, or something else? The next question I want to ask is, what is the center? So there's a minus sign here. This thing indeed is a hyperbola. So again, our next question is, what is the center of this graph in terms of looking at the form? And the center is -2, 5. -2, 5. Why is that? Remember our general form for a hyperbola: x minus a squared over a squared minus y minus k squared over b squared is 1. In this case, h is -2 and k is 5. The next question I want to ask you, is the transverse axis horizontal or is it vertical? And the answer to that question is horizontal, because you'll notice the x comes first. Now, there are 4 points that define the box. So we're starting at our center being -2, 5. The number under the x is 64, so we'll call that a squared is 64. So a is 8, or if you want to say plus or minus 8. So in terms of constructing our 4 points, we're going to go 8 to the left and 8 to the right of -2, 5. So -2 minus 8, comma 5, and -2 plus 8, comma 5. So what's that going to give me? That's going to give me -10, 5, and 6, 5. And our b squared here is 81. So b is plus or minus 9. So our span in the y direction is 9. So we're going to go up 9 and down 9 from our center. -2, 5 plus 9, and -2, 5 minus 9. What is that going to give me? -2, 9 and 5 is 14. And then we have -2, 5 minus 9 is -4. So let's go ahead and graph those 4 points, and let's graph the center on Desmos, and let's do our analysis from there. So we've got our center at -2, 5, and then those are our 4 points. So now we want to go ahead and we want to draw a box. We want to draw a box around those 4 points, and the diagonals of that box will be the asymptotes for this. There's our box, and there's our center. So we have 2 asymptotes. So the next question I want to ask you is, what are the slopes of the 2 asymptotes? So identify the slopes of the 2 asymptotes. So what will they be? This one, rise 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise 9 over 1, 2, 3, 4, 5, 6, 7, 8. So rise 9, run 8. So we get a slope of 9/8. And the other one, down 9 over 8, the other slope is -9/8. So for our 2 asymptotes, our first slope is 9/8. And our second slope is -9/8. Now, what else do we know about this? So fine, we have the slopes of those lines. But the asymptote has to go through the center. So -2, 5 is a point on both asymptotes. So we have a point -2, 5. We have a point -2, 5. So this may be a place where it might be helpful to use the point slope form, y minus y1 equals m times x minus x1, just to emphasize this pattern. So we get y minus 5 is m 9/8 times x minus -2 times x plus 2. Over on this side, y minus y1, y minus 5 equals m -9/8 times x plus 2. So let's go ahead and take a look at those. See if that looks right. So y minus 5 equals m equals 9/8 times x plus 2. And sure enough, that asymptote looks like it is going directly through the corners of that box that we have. And the other one, all we do is we change the 9/8 to -9/8. Going through the other direction. So the next question I have to ask you is, where are the vertices? There are only two vertices of the hyperbola. It's either these 2 points, so what is that, -10, 5, 6, 5, or it's these 2 points, which is what, -2, -4, and -2, 14. So which are the two vertices and why? Well, here's our notion. We have x plus 2 squared over 64. The x comes first. The transverse axis is horizontal. So the vertices are on the horizontal portion rather than the vertical portion. So I have 6, 5, and I have -10, 5. So let's go ahead and put those in a separate spot here. 6, 5, -10, 5, and let's label them as vertices. So if we're going to graph this, what do? We start at the vertices and we draw a hyperbola out towards the asymptotes. So try to visualize what that's going to look like. Starting at the vertices, draw the hyperbola out towards the asymptotes. Let's go ahead and actually draw that and see what we get. That's our notion. So a somewhat challenging thing. You've got to find the center, find the 4 points to define the box, find the equation of the asymptotes, identify the vertices, and then go ahead and construct said vertices. All right. What I want to do next is I want to take a look at the following. We're going to look at 16x squared minus 64x plus 9y squared plus 90y equals -145. And our goal is to graph this eventually and to do the analysis that we need to do. And so how am I going to do that? Well, the x's are together, so I'm going to put them together. 16x squared minus 64x. The y's are together. 9y squared plus 90y is going to equal -145. And I want to go ahead and I want to factor out the 16 here. It'll give me x squared minus 4x. I want to factor out the 9 here. 9 times y squared plus 10y. And our next goal is going to be to complete the square. I want to add something here, and I want to add something there to complete the square. So what will that be? How do we get that? Well, what we could do is we could draw a square and then try to complete it. So I have x squared here, these two things add up to negative 4x, negative 2x, negative 2x. X times x is x squared, x times negative 2 is negative 2x, but negative 2 times negative 2 is positive 4. So I'm going to need to add positive 4 on the left side, and the result, of course, will be x minus 2 times x minus 2, or x minus 2 squared. So the left-hand side is going to become 16 times x squared minus 4x plus 4. Now, how much did I add to the left side? So we have to balance this. So to keep this fair, I've got to add the same thing to the right side. So let me ask you, what do I need to add to the right side to balance out the adding 4 here? What needs to be added to the right side to balance out the adding 4 there? And the answer to that question is 64, because 16 times 4 is 64. So in essence, I've added 64 to the left side, add 64 here. This one, y squared plus 10y plus something, I need to complete the square first. So again, let me go ahead and draw a square for us to complete. Y squared 10y split in half, plus 5y, plus 5y, y times y, plus 5, plus 5. Plus 5 times plus 5 is plus 25. So I'm adding 25 here. So the next question, what do I add to the right side to balance that? What do I add to the right side to balance that? And the answer, of course, is 9 times 25, which is 225. So as we said, the square on the left was x minus 2 squared. This one is y plus 5 times y plus 5, or y plus 5 squared. So we see that. We're ready to go ahead and use that. So where are we? Now we're here, 16 times x minus 2 squared plus 9 times y plus 5 squared equals negative 145 plus 64 plus 225, which gives me a 144. So the next thing I've got to do is I've got to divide everything through by 144. Divide everything through by 144. Divide this first piece by 144. Divide this piece by 144. Divide this piece by 144. So upstairs we have x minus 2 squared. 16 divided by 144 is the same as 1/9. So there's a 9 downstairs. And 9 divided by 144 gives me a 16 downstairs. Oops. So you will notice at this point, what do we have? We have a conic section. We have a situation where the center is 2, -5. The span in x is 3. So my vertices, I'm going to have 4 vertices. A squared is 9, so A is 3, or plus or minus 3 if you prefer. So we're going 3 in the x direction. So going 3 in the x direction, what do I have? 2 plus 3 comma -5. 2 minus 3 comma -5. Which will yield to what? 2 plus 3, 5, -5. 2 minus 3, -1, -5. And to get the other 4 vertices, we are going to do what? We are going to recognize b squared is 16. So b is plus or minus 4. We're going to go up 4, down 4 from the center to -5 plus 4 to -5 minus 4. What is that going to give me? 2 comma -1 and 2 comma -9. So you'll notice I have the center and the 4 vertices that we labeled on the previous page. And we believe that this is going to be the equation that will define that ellipse. And let's see if that's the case. Sure enough, it is. All right, my next question for you is the following. Major axis. Is the major axis vertical or is the major axis horizontal? Is the major axis vertical or is the major axis horizontal? And the answer to that is it is vertical. This is longer. 1, 2, 3, 6 in this direction. 1, 2, 3, 4, 5, 6, 7, 8 in this direction. The major axis is vertical, and the foci, the focuses, land on the major axis. So let's determine how to identify our focuses. So what do we have here? Our equation that we've transformed it into is x minus 2 squared over 9 plus y plus 5 squared over 16 equals 1. Our center is 2, -5. And we want to identify what the focuses are, what the foci are. C squared is the larger number minus a smaller number, which in this case would be b squared minus a squared, 16 minus 9. So C is plus or minus √7. So to determine our foci, we're going to go up √7, down √7. Again, transverse axis is not transverse axis, major axis is vertical. Why? Because 16 is bigger than 9. Greater span in the y direction than the x direction. So we go up √7 and down √7 to get our 2 focuses. So we're going to have 2, -5 plus √7 for one focus, and the other one will be 2, -5 minus √7. Now that should be located inside the ellipse. So let us see if that is the case. Let's take a look at that. As we pull up Desmos. So our 2 foci will be 2, -5 plus square root of 7. That's one of them. And the other one is 2, -5 minus the square root of 7. That's the other one. And we'll label those foci or focus. So those are the 2 focuses. As an ellipse becomes more and more like a circle, the 2 foci converge on the center. As it becomes narrower, they move away from the center. That's the way for us to think about it. And let's remind ourselves one more time of the hyperbola we looked at earlier here. That was the following. That was x plus 2 squared over 64 minus y minus 5 squared over 81 equals 1. And the formula that we need for the focus here, this is a hyperbola. For a hyperbola, the formula will be c squared is a squared plus b squared. So in our case here, c squared is 64 plus 81, which gives us 145, awfully close for c to equal 12, but not quite. So c is plus or minus 145, which doesn't really simplify. Now, the focus for a hyperbola is always on the transverse axis. Here, the transverse axis is horizontal. So we're going to go from the center, our center being what? Center being -2, 5. We're going to go in the root 145 direction in the x direction because it's horizontal. So for our two foci, will be -2 plus root 145, comma 5. -2 minus root 145, comma 5. So looking at that, there's our center at -2, 5. Our two foci about 12 units away in the horizontal direction because the transverse axis is horizontal. So -2 plus a little bit more than 12 is basically 10. -2 minus 12, basically -14. Root 145, pretty close to 12. And there's your two asymptotes. And there is our situation. Remember, if I pick a point on a hyperbola and you take the distance from this focus, distance from that focus, if you subtract those two numbers, that's the same for any points on the hyperbola. The difference of distances is constant. All right, so let's just kind of summarize this with a couple quick questions. If I have the following, if I have 2x squared plus 6x minus 9x squared plus 10y equals some number, we'll make it positive so there's no issues, like 5. What is this shape? Oh, excuse me, let's go ahead and fix that. Let's make it 2x squared plus 6x minus 9y squared plus 10y equals 5. So we'll scratch this. And if I were to graph that, what will that be and why? And the answer is that'll be a hyperbola. The key notion is this minus sign. The x squared is positive, the y squared is negative. That'll give that thing a hyperbola as long as the numbers over here are positive once I complete the square. How about this? 3x squared minus 12x plus 7y squared minus 8y equals some number. And again, assuming that we actually get a graph of something, that it's going to work for us, that we have a positive number on this side, like 13. What is this shape? And the answer to that is this will be an ellipse. And the key idea is there is a plus sign there. So the x squared is positive, the y squared is positive. That will make that an ellipse.